Hello, today we're going to do the positive gradient for cash flows. I've drawn a problem up already. It's showing as a given. We need to find the present value of this gradient that goes up. And this could be a typical type of situation where we may have some investment we want to make and we don't know how much to invest, but we know what our investment is coming out, what we'll be receiving as far as revenue. And the first year it starts out as 100, the next year it starts in year 2 is 150, year 3 is 200, year 4 is 250, and year 5 is 300. And we have a 12% interest rate. And if you look in the front of your cover, you'll see that it looks very similar to the arithmetic gradient on the bottom of the cover page, except the problem is in year 0 we do not have a 0 value. If we look over here to the right of our screen, you'll see here's year 0, here's year 1, 2, 3, and 4. This one only goes up to 4 years, not 5. But a gradient means that this year, the year before the gradient actually starts, has to equal 0. And you'll see here's our gradient of g going up. So this is g, this is 2g, and 3g, and so on and so forth. But the year before the gradient actually starts, it has to be 0 in that year. Well, in this case, that's not typically the case that we have. We see here in year 1 that we have $100. That's more normal, that we'll have some value there. But how do we deal with that when that's not a true gradient at this point? Well, what we can do is we can divide this up into a gradient and a uniform series problem. So let's take a look. We could do a uniform series of $100 for each of these years, right? And then on top of that, we have our gradient. Why didn't that work here? Let's see. And even this year. So then on top, we have our gradient on top. Okay? So we can rewrite this as this cash flow diagram. We can create a new cash flow diagram consisting of 2 cash flows. One being, let's draw this, one being this uniform series which we just created, the green one. So let's do that first. Let's do that green one. So we'll have this cash flow of the green one, and we'll make it light green, going out to year 5. And so here's year 0, here's year 1, here's year 5. And we know that this A value, our uniform series, is equal to $100. Okay, and what we want to do is add on the next part, this gold part, our gradient portion. So let's draw that one. We will have our timeline again, and now we have year 0, year 1, 2, 3, 4, 5, right? And we know this is year 0. This is year 1. We need to have this be 0 in year 1. And if we look at it, if we add these two together, we have 100 from the uniform series. So now we can just add on our gradient. And it starts out at 0 in that year and goes up from there. Okay, and it's going up by a gradient of 50. It's going up by a value of 50 each year. G equals 50. So if we look at that, year 1 is 0 in our gradient, but plus the 100 from the uniform series gives us this $100. In year 2, we have our gradient equaling 50, plus 100 from the uniform series equals the 150, and so on and so forth. We can do that all the way up to year 5. In year 5, we'll have another 150 plus, we'll have another 200 plus our 100 will give us 300 at that point. Okay, so from this, we should be able to write our equation for this problem to solve for P. And you'll see that it's 2 parts. It's broken out into the uniform series, the green portion, and then the yellow-orange portion is our gradient portion. So let's write what P is. We're solving for, so now we're going to have our solution. And we're going to write P equals, what does it equal? It equals our green portion, and our green portion is A, which is 100. So we know it is A. Find P given an A at 12% for 5 years. Okay. And then we have our orange portion, our gradient, which is an addition. And we will have our gradient, which is $50, times P given a G. Find P given G at 12% for 5 years. Notice it's 5 years, not 4, even though the values are only in 4 of the years, right? 2, 3, 4, and 5, and the first year is 0. It is a 5-year gradient. By definition, if you look in the front of your book and inside the book, you will see that first year has to be 0. Okay? So now we can look up in the back of the book and find what these values are. So if I look up in my 12% table in Appendix C, P given A for, let's see where we are, P given A, 12% for 5 years is 3.605. That's a 5. Sorry about that. And the P given G for 5 years at 12% is 6.397. So if we multiply this out, we will have, for the first one, we will have this equals 360.50, 50 cents, plus our gradient portion, which is, let me just multiply that, 50 times 6.397, which is 319.85. And now we know P equals, plus our 360.5 is $680.35. Okay, so there's our solution to this problem. Okay. Some things I want to point out again, some other tricks and things you should look for. Notice that we're looking for a present value. And if we look at this problem, in our numerator of these notations of P, find P given A, we see in the numerator we also see a P. And also find P given G, we find this P, right? The P is what we're looking for, so we should see that in each of the numerators. Okay, so that's how you solve these positive gradients where we have situations where that first year isn't 0. How do we deal with it? We break it off. We'll look at this also as far as negative gradients in the next video. If you have any questions, again, please email me with any questions that you may have of these types of problems.